Hello, welcome to Teach You Why. It seems like the 2021 Physics O-Level paper is much better than the Chemistry paper 2. Regardless of how you do, it's already the past. Hence, this video is solely focused on pure Physics paper 1. As usual, I will be uploading more of this paper 1 walkthroughs before the exam next week. So please share this with your friends and subscribe to the channel if you do not want to miss any more of such videos. As you can see, this video will be on ACS Barker Prelim paper 1 and the link to the paper is as shown in the description below. So without further ado, let's get started. Okay, so for paper 1, right, typically what are some of the clues or some of the tips I offer is that try to keep it within time. And try to think that each question can only be used, you can only use 1 minute and 30 seconds. So try not to spend too much time on this. Okay, so first question, let's go into the first question. First question is on vernier caliper. So vernier caliper, what we need to do is we will see that there is a, we will have a main scale. Main scale is, let's see, this is here. So it's 1.7. So let's write down 1.7. And then you have a vernier scale. Let's see though. So the vernier scale is here. So it's 0.08. Therefore, the external diameter, right, is 1.78 cm, which translates to 17.8 mm. So pay attention that they want the thickness of the pipe, okay, which means that they only want this part. Alright, so from here, we will then need to minus the internal diameter, which is 10.2, which works out to be 7.6 mm. Now, it's not 7.6, but can you see that there's one part here, two part here? So the thickness will be, you need to divide by 2. And therefore, the answer is B. Okay? Okay, body mass index of a person is calculated using the following formula. Mass over height over height. So how do we find the SI unit? So I will just show you what I'll do. You will just write down the SI unit for mass over height. The SI unit for height is meter times meter. And then what you get kg meters inverse 2. Okay, or you can rewrite this as kg per meter squared. Alright, so it's B. Alright, so take note, this is a little bit on math. If you are weak in indices, then you may not know this, what it means by this negative. So negative just means the denominator. Okay. Alright, question 3. Two forces, 6 Newton and 10 Newton, act on an object at the same time, which cannot be the resultant force of the object. Okay, I'll give you the answer. The answer is B. Now, why is that so? Why is that so is because if I have a force acting this way, that's 10 Newton, and then I have another force that's acting this way, 6 Newtons. Okay, so in total, what we can all we can have is 16 Newton maximum. Okay, maximum of 16 Newtons. So it's impossible for me to get 18 Newtons. Now, some of you may ask, so how do I get a resultant force of 8, 10, and 14? Now, I'll quickly explain this without going into too much detail. So for example, if I want 14, right, I can point this 10 here, and then I kind of like have a angled force that is 6 Newton, and the resultant force will be this one. Okay, somewhat like this. Okay, and likewise, you can do the same for all the rest, and that's how you can get the 8, 10, and 14 Newtons. But in short, the main thing is the answer is D. Okay. Okay, question 4. Two identical balls are dropped from different levels of the building. Ball A takes twice the time than ball B to reach the ground. Ignore air resistance. What is the ratio of acceleration of A to B? Okay, so keyword is acceleration. So the answer is A. Why? Because let's say I have A, I have B. Both are being pulled down by gravity, 9.81. Oh, sorry, not 9.81, 10. Okay, 10 meters per second square, 10 meters per second square. Okay, why it takes twice the time is because this is of a higher height and then this is of a lower height. And therefore, if they only care about the acceleration, right, it's 1:1 because they both have the same acceleration. Okay, question 5. Which distance time graph best describes a skydiver jumping off an airplane till he reaches terminal velocity? Okay, so before we start, let's pay attention to the graph first. Okay, so this graph is distance time graph. It's not your velocity time graph. Therefore, A is out. Okay, unless this is velocity, then fine. Okay, you can accept this part. Otherwise, A is out of the question. All right. So before you start any graphing questions, right, pay attention to the axis. The axis makes or breaks your answer. So with distance time graph, what we need to know is that for a dt graph, okay, the gradient is velocity. Okay, so we are interested in the velocity. So let's see. B is definitely wrong. Why B is wrong? Your distance doesn't decrease. In fact, your distance from the airplane increases. So this is wrong. Okay. So we are left with C and D. So which is my answer? Let's see. Okay. So what happens is this. Let's take a look at C. As you jump off the airplane, okay. Okay, as you jump off the airplane, what happens to your velocity? Okay, your velocity will increase and then slowly it becomes a terminal velocity. So it should look like this. Okay, take note, this is a VT graph. Therefore, remember the gradient of distance time graph is your speed time graph. Okay, so what can we say? You look at this ruler. As the time changes, what happens to the gradient? Okay, the gradient is decreasing. So, and then it becomes a constant. Okay, can you see? I don't know whether you can see here. This part here is a constant. Right, so B, C is also wrong. So how about D? How are we sure that it's correct? So let's see. Okay, at first you have no gradient because your initial velocity is 0. And as time passes, the gradient increases until eventually it reaches. You have a straight line here. I don't know. Yeah. Okay, you can see a straight line here. Alright. Yep, a straight line here. And therefore, the answer is D. Okay. I am spending more time than allowed to explain this question. Alright. Question 6. The diagram shows the displacement time graph of a car traveling on a straight line horizontal road. So take note, this is displacement. Displacement means what? I have a reference point. So let's call it a starting point. Okay. So at the start, after 20 seconds, it reaches 10 meters away from the start point. So it actually travels here. Okay, 10 meters. Okay, start point. And then it does nothing. It does nothing here. It just remains here for 10 seconds. And then after, you can see after another 10 seconds, it goes back to my origin because my displacement is 0. And then it further travels to another 10 meters that is behind. Okay, 10 meters, negative. Why negative 10 meters? Because it's behind. So this is a negative, this is a positive. So it's behind my start point. Okay, therefore, what is my total distance? My total distance is 30. Why? You add this, you add this, you add this. Total there is 3 10 meters, and therefore the answer is 30. Alright, moving on. Question 7. The diagram below shows a ball being released on a track from rest to point L. The track is frictionless and air resistance is negligible. Which graph shows how the speed of the ball varies with time from L to M? So they want to know L to M. Okay, so take note, this is VT graph or VT graph. So how will it be like? Quite obvious. From here to here, this green portion and this portion. So this green portion, it will accelerate. Okay, it will accelerate, and then this is where it remains constant. Okay, there's no more acceleration, therefore the answer is B. Okay. Alright, question 8. Block P has twice the density of block Q. Okay, that means to say rho of P is equals to 2 rho Q. Alright, so let's see. And then we need to calculate the, they want us to find the mass. So let's find the volume first. So the volume is 15 times 4 times 3, 180. 8 times 4 times 10, 324. Okay, so now the question now is, what is the mass? What is the mass of block Q? So mass is equals to 180 rho P. Now what I want to do is, I want to write it in this manner. Later you will see why. 180 2 rho Q. Okay, so it's equals to 360 rho Q. Now why we want to leave it in rho Q? Because it's easier for us to make comparison. And then what's the mass of this? Mass is equals to 320 rho Q. So do they have the same mass? No, they do not have. So 8 blocks of P have the same mass of 9 blocks of Q. Now, how do we solve this? We need to do some ratio. So mass of Q, and mass of P over mass of Q is equal to 360 rho Q over 320 rho Q, and rho Q cancel out, and then in short you will get 9 over 8. So mass of P over mass of Q equals to 9 over 8. And then you do some manipulation. Alright. You will get 8m mass of P is equals to 9 times of mass of Q. Therefore, the answer is B. Alright. So this is wrong, this is wrong. Alright. So pay attention to this. Okay, so I repeat, the reason why I want to leave this in rho Q is because we can have a common density for us to make good comparison. Okay, so that's the whole purpose of this. Okay, now moving on. An astronaut lands on a planet where the acceleration of free fall at the surface is greater than that on Earth. Which of the following will remain the same on Earth? Okay, A, to make a stationary object start moving. Height reached by astronaut when he jumps, not possible because you have a different acceleration. Period of a simple pendulum. Okay, period of the simple pendulum is given by this equation, L over G. Okay, so what it means is that the period of the pendulum is dependent on gravity. So if you have different gravity, you wouldn't have a same period. All right. Weight of the astronaut definitely not. Why? Because weight is equal to mass times G. If G changes, your weight changes. Okay, so this is out, this is out, this is out. So the answer is A. Now, why A? What are they trying to say? They are trying to say mass is the same. Okay, so whichever object you bring on Earth to that planet, the mass will remain the same. And if you understand Newton's third law, okay, the law of inertia, right? If your mass is the same, the ease to make a stationary object start moving is the same. All right. Question 10. Which situation illustrates the effects of inertia, a force applying to a shopping cart to give the cart an acceleration? Okay. A moving cart will eventually come to rest. No, it doesn't say that. Inertia says that an object in motion will stay in motion forever. Alright, so question B is out. And moving cart actually in a ideal frictionless world, right, will continue rolling until the cow comes home. Until the end of time, it will still continue rolling. It will never come to rest. That's the effect of inertia. It is difficult to stop a cart moving. Stop a moving cart full of groceries immediately. Okay, I will say the answer is C. Let's see why. The grocery inside the shopping cart will jerk forward when the shopping cart starts moving forward. No, it doesn't. When you push, so imagine instead of using a cart, just imagine yourself in a car. So when the car move forward, you actually feel you are being jerked backwards. Unless you are braking the car. Okay, so unless the car is braking, you feel yourself moving forward. So D is wrong. So the answer is C. A force applied to this doesn't tells you much about the effects of inertia. Okay, so therefore we don't use that. Okay, question 11. The diagram below shows a hinged uniform platform that is held horizontally by a wire stay. Okay, the expression to calculate the tension in the wire stay is correct. Okay, so we will use the moment equation. Moment clockwise equals to moment anti-clockwise. So moment CW must be equals to moment ACW. So what are your moments that is clockwise and what is the moment that is anti-clockwise? So the weight is anti-clockwise, so it's clockwise. Therefore, it will be P over 2 times W. Okay, which is your weight. Must be equals to the perpendicular distance, okay, from the hinge to the tension. So the perpendicular distance is Q, and therefore is TQ. Therefore, the tension T is, if you do some manipulation, it will be P over 2 times weight over Q. So let's see whether we have any of this. P over Q, P over. Okay, so pay attention, is B. So take note, this is divided by Q. So don't be sharp with your eyes, okay? Yeah, that's all. So answer is B. Alright, so question 12. Which modification will enable the heavier load to be lifted? Now, this is a hydraulic system. So you learn from hydraulic system is that the pressure on both ends, right? So P1 and P2 is the same. So P1 equals to P2. Now, what is P1? So P1 is equals to force divided by the piston W, okay, area of piston W. And then P2 is equals to load divided by area of Z. Therefore, force is equals to L over AZ times AW. Okay, so the force required is equals to the load divided by Z times the area of W. So what can we do to enable us to lift a heavier load? So let's see. when we double W, so when this increase, okay, so what they are trying to say is that when this increase, this will increase. So we do not want this. When W increase and remains the same, okay, we also do not want this. When W is half, okay, so which means that area reduce. This one, this area increase. So what happens is that with this, right, with this relationship, when area of W decrease, my force decrease, and then when area of Z increases, right, because it inversely proportional, it further decrease F. Therefore, our answer is C. Okay, I hope by using this this equation, it makes better sense on how we can answer them. Okay, 13. The energy input to a motor is 300 watts. In 20 seconds, it lifts a load of 400 newtons through a height of 6 meters. What is the efficiency of the motor? So this should be quite straightforward. Efficiency is useful energy over total input energy. Okay, so what is my useful energy? My useful energy in this case is 400 times 6. What is my total energy input? Will be 300 times 20, because power equals to energy over time. So energy equals to power times time. Okay, therefore we have 2400 over 6000. The answer is times 100%, you get 40%. Okay, all right. In Brownian motion, so in Brownian experiment, smoke is used because smoke particles are big enough to be seen and light enough to be affected by air particles. Yeah, there's the answer. Let's see why B, C, and D is not. Are black and can be easily identified through microscope. No, not necessary. My keyboard is black. My pen is black. My Samsung earbud is black. Doesn't mean that we use it as a Brownian experiment. Okay, so it has nothing to do with it being black and easily identified. Right? It needs to be small and can be affected by air particles. Okay, can restrict the motion of air particles. Doesn't really say much. So what if you can restrict? Like I said, I can restrict the air particles, you can restrict the air particles, my book can restrict the air particles, my mouse can restrict the air particles. We don't use it in Brownian experiment. Okay, so no. D, serve as a good contrast for air particles to be seen. Not really. Not necessary. Even air is now in front of me. Okay, I have a white wall in front of me. It shows a good contrast. White usually is a good contrast, but I cannot still see air particles. Therefore, D is not good enough. Hence, the answer is A. Alright. Question 15. The diagram shows a section through a particular type of building board, which explains why such board provides good heat insulation. Okay, they want insulation. Therefore, the aluminium has to be good reflector because it's shiny. Okay, good reflector means less heat transfer via radiation. Poor conductor of polystyrene, yes. Compressed paperboard has to be of low thermal conductivity. Low thermal conductivity means poor conductor. Therefore, is D. Okay. The contents of a cooking pot continue to boil for a long time after it has been removed from the stove. What could be a possible explanation? Okay, so I'll give you the answer. The answer is D, A. The pot has a very high high specific heat. Now, why is that so? So the thing is, most of the time, the pot, right? Okay, if you notice, usually, if you eat steak or if you drink soup or what, right? Sometimes they serve the steak on a very hot plate. Okay, for example, hot plate. Or in Singapore context, it could be your hot plate tofu. Okay, when it's served, the zi char store person come in and serve you the tofu, you can still see the tofu bubbling. Okay, bubbling. Now, why is that so? Is because, right, the hot plate has the ability to keep the heat. Why is that it has this ability to keep the heat? Is because it has very high heat capacity. That means all the heat is being trapped inside this this hot tray, or sometimes could be hot pot. Okay, your clay hot pot. Another one is your clay hot pot. I can't draw properly, but you get my point. So if you were to have any clay hot pot for dinner, I don't know what kind, you will see that they continue to bubble even though when the server serves the food onto your table, you can still see some bubbling until it eventually stops. Okay, it's because of all the heat that is being trapped, okay, onto the pot, and therefore this is the reason why it continues to cook the food. Okay, so I spent a little bit time to explain this, otherwise I can't really explain why the answer is A. Okay, now question 17. A block of ice minus 10 degrees C was heated. The ice has a lower specific heat capacity as compared to water. Which one correctly illustrates the heating curve? So let's see. Definitely D is out because there is no straight line here, because you need time to melt the ice. So let's see. Definitely C is out. Why? Because the gradient, right? The gradient of this graph, this is your ice. This is gentle. Okay, so the gradient is gentle. Gentle means more heat capacity. How come more heat capacity? Because if you see, based on logic, right, it means that it takes longer time. Okay, it takes longer time to reach this temperature. Okay, so which means that if you have higher heat capacity, it means that you need a longer time to heat it, a longer time to reach a certain temperature. But it's not the case. They already say ice has a lower heat capacity as compared to water. Therefore, D and C is out. So left with A and B. So my answer is B. How come? Because let's see. Let's use the ruler. Okay. It's 48 degree, and then let's compare. This is 48 degree, which means that both for A, right, this gradient and this A gradient, they are the same. And they are the same means they have the same specific heat. Therefore, answer A is wrong. Hence, my answer is B. Okay. A fixed mass of gas is kept at a constant temperature. When the volume of gas increases, the pressure decreases. Okay, why is that so? The molecules are further apart and they collide less frequently. Answer is A. Definitely not further apart and they move slower. Slow or fast has got to do with your temperature. Okay, this is constant temperature, so same speed. Okay, so fast or slow, I repeat, fast or slow is dependent on temperature. So because they say that it's slower, it means the question never say that the temperature dropped. The question only say it maintains at a constant temperature. Hence, you cannot say that it's moving slower. Molecules are moving slowly. Okay, anything that is changing the speed is wrong. Anything that is changing the speed is wrong. So therefore, the answer is A. Alright. Moving on. A sample of candle wax mass 200 grams completely melt in 4 minutes when thermal energy is supplied at a constant rate of 12,000 joules per minute. What is the latent heat of fusion for candle wax? Let's see. Total energy is equals to 4800. Why? Because this times 4. Okay, 4 minutes per. Alright. So total energy, and then how many grams? So latent heat, right? L is equals to Q over Okay, this is my Q. This is my mem. So cancel, 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 cancel. 240. Answer is 240. Okay, I'm doing this very quickly because I'm trying to complete this in 1 hour's time. Alright, so which changes of state occurs as a result of gain in thermal energy? Okay, so in order to gain thermal energy, boiling, you need to supply heat to boil, you need to supply heat to melt. Solidification, no, is to remove heat. Condensation is to remove heat. Condensation is to remove heat. Solidification is to remove heat. So therefore, answer is A. Quite straightforward. Question 21. Which of the diagrams shows the incoming parallel lines 1 and 2 which passes through a thin converging lens? Which point A, B, C, or D will light through passes through? The answer is A. Now, okay, let me explain. This is what we call a focal plane. Take note, this is what we call the focal plane. Which means that if I have light of the parallel that are parallel, right? Okay, they will again meet at this point. Even if I have another light that is parallel, okay, it will also meet at this point. Alright. So likewise, if I have light that is parallel, okay, let me use another color. Parallel to light 3, it will also meet at this point. Okay, so what do we learn? We learn that lights that are parallel, okay, they will all meet on this focal point. Focal plane, not focal point. This is your focal point. This whole thing here is your focal plane. So if let's say I draw another diagram, okay, I spend some time here because this is quite a question where most students will struggle. So let's say I have a parallel lights like this. Okay. And then this is my F. Therefore, this entire thing is what we call the focal plane. Okay? Focal plane. Don't confuse with focal point. This is focal plane. And I may have light that is... Okay, so these three lights are parallel. So they may converge here. Okay? So that's the whole idea of focal plane. Alright, is that lights that are parallel, right, they will converge on the focal plane. Okay? Now, moving on. 22, what is the refractive index? Ratio of speed of light in air to speed of light in glass? No. Okay, the correct definition is the ratio of speed of light in vacuum to the speed of light in glass. So in fact, your air, right? Air has a refractive index of equals to 1.02. Okay, about there. So it's approximately equals to vacuum lah. Okay, so that's why we usually assume that air and vacuum, they are the same. Okay, so okay, now 23. 4 students PQR are standing in front of a plane mirror as shown. Who can QC? Okay, so this kind of question, right, what we want to do is we will need to draw. Okay, we will need to draw the virtual world and then the actual world. So Q here, here. So this is your P. So here, here, and here. This is your Q. Your R. Reflect here. This is my virtual world. R. And S. And then S will be here. Now, so we want to see Q. So Q, right? Let's see whether Q can see. Can Q see P or not? Cannot, because this region here, okay, this region here has no mirror. Okay, no mirror means light cannot bounce. Your light, right, cannot bounce here to go to his heights. So this cannot happen. Okay, let's see. Let's see whether you can see R or not. So Q meets R. Yes, you see, it meets at a mirror. So yes, it can bounce off. Therefore, you can see R. And let's see whether you can see. Let's see whether Q can see S or not. Okay, and yeah, you can see S as well. Alright, so it's R and S. C. Okay. 24. The diagram shows a transverse ray traveling from left to right. In which direction are the particles moving? Okay, so what we're going to do is, we are going to draw the same graph, same wave, just that is shifted. Okay, now in exam you can't do this. Okay, in exam you can't do this, but you can imagine it. So I'm going to shift it to the left, like this. So what you're going to see, what you're going to observe is, S has moved up, R has moved down. Okay, in the next instance. Okay, because the blue line represents the next wave that is being created. Okay, so S has moved up, R has moved down. So the answer is S upward, R downward. So it's B. Okay, the diagram shows the variation of displacement of a wave with time. Okay, what does segment PQ on a time axis represent? Okay, it represents half the period. Now, why? So pay attention. Your wave has two graphs. Okay, you have your displacement distance and your displacement time. Okay, so two different graph tells you two different things. If you have a displacement time graph, okay, this length here, this is a displacement time. So this length here represents the time that it changes. So where is one period? The one period is from here to here. So therefore, from here to here is half a t. Okay, therefore is 8. Okay? Okay, question 26. The figure below shows a water wave traveling in ripple tank. The wave front at X travels to Y in 5 seconds. What is the frequency of the wave? So, first of all, these are all wave fronts. Okay, so which means these are the maximum. Therefore, here to here is 1 wavelength, 2 wavelength, 3 wavelength. Therefore, 3 lambda is equals to 15. Lambda is equals to 5 cm. Now, but they want to find frequency. And what can we do? You have your distance, you have your time. So your velocity of the wave is equals to 15 over 5 equals to 3 cm per second. Okay, so V equals to F lambda. So F is equals to V over lambda. So equals to 3 over 5. Therefore, we get 8, 0.60. Okay. Alright, moving on. Set 27. Which row does not show a correct application of the state of the stated electromagnetic wave? Let's see. X-ray detecting cracks in building. Possible. We can use X-ray. Radio wave satellite TV. No, satellite TV uses microwave. Okay. So it's B. B is wrong. Gamma rays for medical treatment. Yes, you use gamma rays for radiotherapy for cancer patients. D, ultraviolet radiation for sterilization. Yeah. Okay. So B. So satellite TV, I repeat, is microwave. Your phone also speaks to the satellite. Therefore, it's also using microwave. Okay. What is the speed of air in water and in concrete? Okay, the answer is quite straightforward. It's A. From air is the slowest, then water is the second fastest, and then concrete is fastest because sound can travel faster, way faster in solid because the particles are more closely packed compared to water and compared to air. So answer is A, quite straightforward. Okay, so I won't explain too much about this. Why is A? 29. The diagram shows the resulting sound wave produced by the speaker. Okay, how does the sound produced by the speaker varies as time passes? So let's see. If you were to compare this, the wavelength all remains the same. Okay, so if the wavelength remains the same, which means we cannot say that the pitch changes. We can only say that the answer is it becomes less loud. Why? Because you see the amplitude, okay, is getting smaller. So the amplitude of the amplitude of the sound represents the loudness of the sound. Okay, so amplitude reduced means the sound has become less loud. Which statement of electrostatic charge is correct? An electron will move at a constant speed in an electric field. No, okay? It doesn't move at a constant speed, okay? Why? Because it's in a force. So by right, it will accelerate it's experiencing a force in an electric field. Therefore, it will accelerate more than it move at a constant speed, okay? An electron will always move towards a positively charged in a straight line. Okay, let's see whether this is true. This is debatable. Okay, let's put a star. The direction of the electrical charge at any point in direction of the force on a small positive charge at the point. Okay, so basically what they are trying to say is the definition of the lines. So let's say I have a point charge, positive. Yes, it will fly in the direction of the lines. Okay, so the answer should be B. Or should be C. When two electrons are brought close together, their electric field interacts and result in an attractive force. No, it doesn't attract. Okay, so D is wrong. So let's see why B is wrong. An electron will always move towards a positively charged in a straight line. No, not true. Not true. So let's say I have a positively charged connected to a negatively charged. Okay. So what's gonna happen is that the electrons, right, will actually curve the electrons. You see these few lines, right? These few lines are curved, which means the forces it experiences are kind of curved. Therefore, it doesn't move it will not move in a straight line. Okay, so answer is this is wrong. So answer is C. Alright, the diagram shows the electric field patterns between two electrical charge L and M. Which statement is correct? So, because it's pointing outwards, definitely they needs to be positive, and therefore answer is A. Alright, so take note of the direction. If it's negatively charged, right, the arrow should be pointing in. Okay, the arrow should be pointing in if it's negatively charged. But this is positively charged, therefore it's pointing outwards, and hence yeah, you can't say that they are both negative. L are positive and M is negative. No, it doesn't. If it is positive and negative, it will form a few lines, something like this. Okay. Yeah. Okay, moving on. 32. The diagram shows a resistor connected to a battery. 4 joules of energy delivered by the battery to the resistor. 5 coulombs of charge flow through the resistor in 1.5 seconds. Which statement is correct? Okay, so let's see. Let's find the voltage. So the voltage will be V is equals to E over Q. So 40 over 5 is equals to 8 volts. What's my current? My current I is equals to Q over T equals to 5 over 1.25. you get 4 ampere. Okay, so the current flowing through a battery is not this, not 6.25 volts. EMF is 8 volt. Yes, answer is this. Power dissipated is 50 volts. 50 watts. No. 80 power equals to IV. So 8 times 4 is equals to 32 watts. So no, it's not 50. 50 watts. Resistor or a resistor is 32 ohms. We can't tell. Okay, we can't tell. It doesn't say anything. We can't tell. Okay. Oh, sorry. We can tell. Sorry. R is equals to V over I. Okay, so it's 8 over 4 is equals to 2 ohms. Alright, so answer is B. A wire has a resistance 8 ohm. A second wire made of the same material has half the length, twice the diameter. So R equals to rho L over 8. Now, what will be my new length? My new length will be rho half L over, what is my area? Area is equals to, they say twice the diameter. So area, right, will be equals to 4 times my original area. Okay, 4, 8. And then if you were to factorize this, what you will get is equals to 1 over 4 divided by 4 rho L over 8. Okay, so this thing is 8. So here is 1 over 8 times 8 equals to 1. 8. Okay, so now I get another question. How come I double my diameter, my area becomes 4 times? Because area is pi r squared. Because of the square, if you double the radius, okay, because of the square, it increases by 4 times. Increases to 4 times. Okay, so take note. Common mistake is they always try to trick you with the word diameter. Okay, if it's diameter, double the diameter, the area will increase to 4 times. Okay, unless they say twice the area, then you just put 2a, right? Okay, so 34. How much charge passes through a point in conductor if 6 milliamp flows through the point in 10 minutes? Okay, so how to find charge? Q equals to IT. So 60 times 10 to the power minus 3 times time. My time is 10. And then it needs to be in seconds, so it's 60 seconds. Therefore, we have okay, the answer is C. Okay, so 36. Okay, just press your calculator, you can get this answer. A bird can stand on an overhead high voltage transmission line without getting electrocuted. Which statement correctly explains the situation? Both feet of the bird are of the same voltage. Yes, A. So the thing is, it is the potential difference that allows current to flow. I repeat, it is the potential difference that allows the current to flow, but not the voltage. So for instance, let's say I have a 10,000 volts wire. Okay, so if the bird is, okay, not a very nice bird, but whatever, standing here and here, what is my voltage here? My voltage here is 10,000 volts. 1,000 volts. My voltage here is also 1,000 volts. And what's my difference between these 2 points? My difference is 0. Now, when will the bird die? Okay, or get electrocuted? You get electrocuted when, let's say, I have a bird, right? One leg here, one leg here. So let's say this is 1000 volts. And this is 500 volts. Now, what is the delta V here? Delta V is 500 volts. And therefore, there is the the current will flow from high potential to low potential, and that's where it will get electrocuted. But if both legs are of the same voltage, right, there is no difference for the current to pass through. Okay. 36. In the circuit shown, R is a light dependent resistor. What effect does an increase in light intensity on R have on the brightness of two lamps L and 2? So what we're gonna learn is that when this increases, R will decrease. Okay, so light dependent resistors, right? When the light increases, the resistance decrease. Therefore, what's gonna happen? Brightness of the two lamp. Okay, so this has the same potential difference. So if L1 will remain the same. Okay, remain the same. Let's see. When my resistance drop, okay, the current here, okay, the I here, okay, because my R drops, my I here will increase. Therefore, L2 will increase in brightness. Therefore, answer is D. Okay. The metal case of an electric heater is earth. The plug of the heater contains a 5 ampere fuse. There is a current of 4 ampere when the heater works normally. The cable to the heater becomes so worn that the live wire makes electrical contact with the case. What happens? Okay, so if the live wire makes electrical contact with the case, the fuse will melt and switch off. Why? Because, right, let's say I have a case. This is my heating element. Now, let's say the wire, it got so used and then it touched the case, the metal case. Now, because a metal case is a good conductor, right? So this is a good conductor, right? The current can flow around the case very, very quickly with low resistance, which means that the current going in will no longer be 4 ampere. It will become much higher than 4 ampere. It will only be 4 ampere if it passes through the heating element because it has resistance. Okay? Therefore, when it touches this, right, it will cause the current to be so high that it eventually melts the fuse. Therefore, answer is B. Okay? Now, 38. The figure shows a small plotting compass placed above a copper wire when there is no current in the wire. The plotting compass points to the north. Okay? When a large current passes through the wire, the direction of the wire is as shown above. Okay, so the current is here. So if you have watched my earlier video on how to use right hand grip rule, we'll use the right hand grip rule here, because then your finger is here, use your right hand, and then you point. This is your current. Okay, this is your current. And therefore, we have what we have is that we have this magnetic field that is in this manner. So this is this part here is the behind, this part here is in front. So if let's say, so here, right, I put a dotted line and then I put this one is the in front. Okay, 3D view. Okay, so what will happen is that the compass, right, will tilt in the direction of this my compass, right, will tilt this way to meet this direction. Therefore, my answer is D. Okay. So which diagram below shows the diagram below shows an electron passing through a magnetic field. Which diagram is correct? Now, take note. One thing that most students get it wrong is for electrons, right? If electrons fly, if I have a negative charge that is flying here, my current I, right, is considered here. Okay, if I have a positive charge that is flying here, then my current is considered here. So if you were to use your Fleming left-hand rule, okay, on diagram A, B, D, okay, you will realize that the answer is B. Okay, you point your B field into the page, you point your current. So my current is actually here. This is my current. This is my B field. Okay, B field. Okay, into the page. You will notice that there is a force that is perpendicular to the direction of the velocity or the path of the electrons. Okay, so answer is B. Okay, last question. Each diagram below shows a cross-sectional through a true parallel current carrying conductors. Okay, which diagram correctly shows the magnetic field patterns formed by the currents in two conductors? Okay, so as usual, I will do this. So we have inside and then we have outside. Okay, so if you use your right hand grip rule, okay, this will be this. Okay, the magnetic field is as shown in the blue, and then we have okay, so pay attention to this part here. Okay, this part here, right, you will notice, if I can draw again, this part here, you have two magnetic fields that are in the same direction. Therefore, what will happen is that they will reinforce each other, okay, to downwards. So we see something like this. So the answer is C. Okay, so take note, A is wrong because the direction is wrong. This is up. It doesn't cancel out. Okay, so no. Yeah, so the answer is C. Okay, so yeah, okay, so therefore what will eventually happen is that there will be a force repelling both of them because the center magnetic field is stronger than the outside magnetic field. Okay, so the answer is C. Okay, that's it for paper 1. So as I mentioned earlier, please stay tuned to this channel because I will be uploading some of the paper 1 physics and chemistry walkthroughs. Okay, and I hope that you guys can take some time to relax after all your paper 2s, but also not to relax too much because you still have paper 1 that can help you with your grades or even help you pass if you were to do sufficiently well. Okay, so especially for those who want to aim for an A, your paper 1 is extremely important. Okay, so that's it for this video. I will see you guys the next time. All the best for your exams and bye bye.